Okay.
Okay, 7 minutes from now.
Okay, thank you. Hi everyone. This is Omar. This is Omar Al-Twaini from Research Institute of Geohydrological Protection and Italian National Research Council, speaking on behalf of my colleagues. So today I'm talking about developed tools actually for what's so-called DUCE, which is a QGIS toolbag for the automatic selection of reference rain gauge for landslide triggering rainfall thresholds. Next. So in early warning system, as you know, the threshold is the most significant part, which is used to associate the condition of the high probability of landslide occurrence, and it's mostly depend on the data of the rainfall. In this case, we say the rain gauge rather than using the satellite or the radar data. So it's used to construct the threshold. However, come to interesting, following the literature by a paper presented by June 2018, that 25% of most of the papers that they scanned, that it's missed the component of how did they select the rain gauges. And this is, I quote, that is surprisingly that in about 25% of the analysis threshold, a clear description of the method adopted for rain gauge selection is missing. And in another paper by Guerin 2020 also came to the conclusion that most of the rain gauge selection, that it was not consistently following one procedure. However, in overall, they all mostly depend on the distance. Next, please. So come here to some normal scenario that you can see that next there is a relationship now. If you see next, please, there should be, yes. You can see the rain gauge here and the landslide, the red one. That okay, this is the typical scenario that we have a distance and they are following selection of this rain gauge. Next, please. Also here we see that the vicinity also applied, that between this landslide and the right side, on the left side we have the rain gauges. Next, please. So also you can see here the variation in the distance and in the elevation is not that drastic. Next, please. However, in this point, it's an interesting fact that it's a tricky scenario. Next. You can see now there is like a 10-kilometer distance between the station and the landslide. However, on the right side, we have a closer distance. However, we have a different watershed in this setting. So this comes to a question that selecting of the landslide represented rain gauge, shall it just follow the distance? Next, please. And by following a paper by Susan and Kaya 2011 and quoted, and 2015 by Budimir, that a few conditions actually, like environmental, geotechnical, topological, all they are represented to initiate this hazard. So overlooked most of these factors by considering only the rainfall, it's not the correct solution. So in this research, we are including this kind of settings, which is the hydrological and topological, and also, next please, we have included the slope unit component, which is the slopes homogeneous surface that is connect the slopes within a specific aspects, that it can be also useful in case of a very high density study area, like for example in Kuala Lumpur of Malaysia, or in Seoul of South Korea, that when you have the landslide happen in the urban area where they are surrounded by too many rain gauges. And so this is, we are trying to come up with some improved threshold by following this concept. Next, please. So now how to decide actually the most relevant rain gauge? So by construction, either by selecting the closest one or by trying to investigate the environmental and topological relationship. Next, please. So now the objective of this research is to develop the tool that it's a free tool that is built on a criteria of automatic selection of the rain gauge based on the distance, additional the elevation, the watershed, and the slope unit with very simple inputs like the dam, landslide inventory, and rain gauge, and other settings that are already defined by default based on the literature. Next, please. So this tool actually developed, and it's completed, and later on it's integrated actually with the CTRL tool just to see the reflection on the improvement of the thresholds. So on the left side you can see this is the tool. It's just purely work on Windows and it's based on the QGIS. On the right side it's the CTRL based on the R. So now in the paper that it's written, it's full of the two methods, and now in just this presentation we focus on the tool itself of the views. Next, please.
1 minute.
I'm losing the switching. Sorry. Please next. Please next. Because it has, okay, so this is the logic behind the tool, that okay, we apply a condition that we have a priority for the distance, however it's followed by the slope unit, then watershed and elevation, and also the tool makes sure that we have a minimum one rain gauge related to one landslide as a minimum. Next. And this is the back end of the tool. So you can see it's developed in the tool processing tools, and also we have the GUI, the simplified one, and additionally it can be run using the Python. Next. And here the study area, and we will just quickly because of the time. So we have in Southern Korea, and it's a regional study. Please next. So this is the applied the first filters on the right side, left side it's the distance, on right side is the watershed. Next, please, just to catch the time, and we come to the conclusion. And here is the slope units, and we can see here this is the matching with the criteria. So the one that highlighted, they are actually the match the filters. Next, please. Here is now we come to the interesting conclusion. So we applied 10 trials, one using the CTRL alone within the predefined distance, and then with other 9 filters combination in differences. So next, please. So now you see here now the result come out while using in the first case almost 200 rain gauge for the landslides that we have. We reduce the amount of the landslides, or the rain gauges, and up to 125. So it's almost 30% we reduce. And also interestingly, so you can see the unique rain gauge. Please next. The unique rain gauges, they are representing the rain gauges that used to construct the threshold. So you can see here that changing those filters and increasing the filter robustity, you can see still we are getting almost similar amount of rain gauges that are used to construct the suspicious rainfall events that cause landslide. Next, please. So, yeah, this is now we come to conclude, and this is the two thresholds that developed by the northern of study area and the southern of study area, and you can see here all the threshold almost getting the similar values, even though the first one, as we said, the first case is the worst case, using almost 200, more than 200, and the cases that we come to the conclusion, it came with almost 30% reduction. Next, please. So in the last slide, we said that rain gauge recorded by optimized 33% using the DUCE tool, and it's not about installing greater amount of rain gauges. However, considering environmental topological correlation for future work, you can consider selective of the landslide events, and this use can be used by non-experts, fast processing, user preferences, and also it's open for all to be used. And thanks a lot for your time and your patience.
Thank you. Next speaker is on site.